Hello everyone. Today, we will learn about the mechanical properties and requirements of the subgrade as part of the design and reading of subgrade structure diagrams. First, please think about what kinds of forces act on the subgrade. What are the characteristics of these forces? Based on the soil mechanics content we've learned before, we know that the subgrade is subjected to vehicle loads transferred from above through the pavement and the dead weight of the subgrade in pavement. As you can see, sigma 1 represents the curve of additional stress caused by vehicle loads as a function of depth, which decreases with increasing depth. Sigma 2 represents the curve of the deadweight stress of the subgrade in pavement, which increases with depth. This is the characteristic of how the subgrade is stressed. Here we introduce the concept of the work area of the subgrade. At a certain depth in the subgrade, when the ratio of additional stress caused by vehicle loads to the deadweight stress of the subgrade in pavement is between 1/10 to 1/5, that depth range of the subgrade is the work area. Vehicle loads have a significant effect on the subgrade soil within the work area, while the influence outside of the work area is negligible. Therefore, if the height of the fill in the subgrade is greater than the depth of the work area, the impact of vehicle loads on the natural foundation can be disregarded. If the height of the fill is less than the depth of the work area, it means that vehicle loads will affect not only the embankment, but also the upper soil layers of the natural foundation, which need to be sufficiently compacted to meet the requirements of the work area. Hence, the work area of the subgrade has guiding significance for how to treat the natural foundation. The work area of the subgrade increases with the increase in vehicle load and decreases with the increase in the strength and thickness of the pavement. Damage to the pavement structure is not only due to its own causes, but also significantly due to excessive deformation of the subgrade. Deformation of the subgrade soil includes elastic and plastic deformation, where excessive plastic deformation can lead to ruts and longitudinal unevenness in flexible pavements and cause fractures in rigid pavements. Excessive elastic deformation can lead to fatigue cracking in asphalt surface courses and cement concrete panels. Soil is a nonlinear elastoplastic deforming body. Experiments show that soil deformation under stress includes recoverable rebound deformation and irreversible residual deformation. When the load is removed and stress returns to zero, the curve goes from point A back to point B, with OB representing plastic deformation. Depending on the method of stress value selection on the stress-strain curve, there are 4 types of moduli: initial modulus, tangent modulus, secant modulus, and rebound modulus. The first 3 moduli include both residual and rebound strain values, while the rebound modulus includes only rebound strain, reflecting the elastic properties of the soil. In pavement design, the rebound modulus is typically used to represent the compressive strength index of the subgrade. Subgrade strength refers to the subgrade's ability to resist relative sliding displacement deformation and vertical settlement deformation under external force and deadweight. The indicators representing subgrade strength mainly include the subgrade's bearing capacity and shear strength. Parameters indicating subgrade bearing capacity include subgrade rebound modulus, California bearing ratio, or CBR, and subgrade reaction modulus. The shear strength of soil is usually expressed using the Mohr-Coulomb formula. The rebound modulus reflects the subgrade's property of recoverable deformation under instantaneous load and is usually determined by pressing a circular bearing plate into the subgrade. The California bearing ratio is an index characterizing the strength of subgrade soil, granular material, and stabilized soil. It is the ratio of the test load applied to a standard specimen at a certain penetration to the load applied to standard crushed stone material at the same penetration, expressed as a percentage. The subgrade reaction modulus is based on the Winkler foundation assumption, where deflection L at any point on the subgrade surface is directly proportional to the vertical pressure P at that point, unrelated to the pressure at adjacent points, assuming the subgrade is equivalent to a series of disconnected springs applicable to rigid pavement analysis. The current Chinese design standard for asphalt and cement concrete pavement design uses the rebound modulus as the design parameter for subgrade pavement and the CBR index as the basis for subgrade filler selection. The shear strength of soil indicates the soil's capacity to resist shear failure, usually represented by the Coulomb formula, with C and phi values being the shear strength indicators, reflecting the magnitude of the soil's shear strength. Factors affecting subgrade stability mainly include engineering geological conditions and hydrogeological conditions, hydrological and climatic conditions, subgrade design, construction, and maintenance measures. Good geological and hydrogeological conditions are the basic premises to ensure subgrade project quality and prevent diseases. Water is the main cause of subgrade diseases, so as engineering practitioners, one must possess the professional quality of adapting measures to local conditions and comprehensive consideration. Before design, detailed geological and hydrological surveys should be conducted. Based on specific conditions and the composite effect of various factors, correct design and construction methods should be adopted to ensure the quality of the subgrade projects. Thus, the subgrade cross-section shape and size need to meet the standard requirements, ensure the overall subgrade does not produce unacceptable deformation and damage under vehicle and natural factors, have the ability to resist deformation and damage under vehicle load, and maintain its strength under the effects of water and temperature. That's all for today's class. Thank you.